I'll be doing number 49 on the chapter 4 homework. And the question states, find the acceleration reached by each of the two objects shown in the figure if the coefficient of kinetic friction between the 7 kilogram object and the plane is 0.25. And this is my free body diagram. And I just set that the 7 kilogram block is M1 and the 12 kilogram is M2. And we know that this block will move upwards and this one will move downwards since this one is heavier. And for the M1, there's the normal force, which is perpendicular to the ground, friction, weight, and tension. And for M2, there's only tension and the weight. And we could solve for the sum of forces, which is mass times acceleration. And we could use these numbers to plug it back in into our final equation. For my M1, my sum of forces equals tension minus friction minus mg times sine 37 equals ma. And my M2 sum of forces equals mg minus tension equals ma. And we could isolate tension in the second equation and then plug it back into the first to just have one big equation to solve for acceleration. And this is my final equation. And for friction, since we know that friction equals mu times normal force, it'll be 0.25 times mg cosine 37. And we just plug that back in here. And after that, I put all the acceleration units on one side. And after, I just plugged in all my numbers. And for like M2G and M1G, I plugged in the numbers I found here. And I got 62.65 equals 19 A, and acceleration equals 3.3 meters per second squared.